So, welcome again. We are now solving the capacitor systems, and this is the capacitor system 2, that is the second part of the capacitor system we are taking around. And the problem given to us is a metal ball with a radius of 10 centimeters is concentrically placed inside a thin walled metal ball. That is precisely a thin metal sphere, not filled, with a radius of 20 centimeter, and the inner ball is grounded somehow through the opening in the outer sphere with a very long wire, and the outer sphere is charged to 10 to the power minus 8 coulomb, and we need to find the potential of the outer sphere. So I just indicated the radius of the outer sphere by capital R, and suppose it has got charge Q because it is already provided in the statement of the problem that it is charged, and so I'm taking its charge equal to capital Q, and the radius of the inner ball, metal ball, that it is with the radius small r. And I'm going to consider a few cases first, and let's consider first the case where the inner sphere is not grounded, though the problem says it is grounded, but I'm assuming in the as our first case when the inner metal ball is not grounded, and at this point its potential is equal to that of the outer sphere, of course, and its potential can be simply written as phi r, that is equal to phi capital R, because both the spheres will have same potential, and you can write it as kq upon capital R. This is our first equation. And let us take the case when the inner ball has a charge, suppose q dash, because it is connected to the earth, so it can now I'm not considering the case when inner sphere is not grounded, rather I'm going to consider that case in which the inner sphere, the inner metal ball is grounded, and it can get some charge from the earth as well, and suppose that the charge on it is q star or something, or q dash, and I'm also considering the case when this inner ball has a charge this much q star and outer sphere is uncharged, and in this case the potential of the inner ball can be simply written as phi star, yeah, I can write it, equal to kq star upon r, and the potential of the outer metal ball that can be written as simply as phi or phi r. If you like, you can place a small r here as well, and phi r can be written as k q star divided upon capital R. And now I'm going to superpose the situations. I'm thinking that if both metals, if the both spheres have charges, and we have a combination of the above two cases I was earlier considering, so which can be found by summarizing the charge and potentials, and since inner ball is grounded, so its potential must be equal to 0, because it is assumed that the potential of the ground is always equal to 0. So I can write here something like this case, phi r plus phi dash r, both cases superposed, and that will be equal to 0. And so that I can write the equations kq upon r plus kq star upon r, and that is equal to 0. And that of course gives us q star equals minus r upon r q. And now we can also find the potential of the outer sphere, and that is required, and that can be written as ur in the same manner, ur or phi r. I was earlier writing the potential as phi, so it is phi r plus phi star r, and you can write both of them as kq upon r plus kq star upon r. And we know the value of q star, and we can put here, and we can get the result that will come out as kq upon r 1 minus small r by capital R. And if you put the values, proper values given in the statement of the problem, you will get the result as it will come out as 225 volt. So thank you very much for watching, but let me continue to another case, because some other cases can also be considered based on capacity of a spherical capacitor. And we all know that capacity of a spherical capacitor can be written as 4 pi epsilon naught 1 by r1 minus 1 by r2, and r1 and r2 are inner and outer radii. And the layout in this problem says that we have a parallel combination of two capacitors. The first is a spherical capacitors having radii small r and capital R, and second sphere is of course a capacitor having charge R only, capital R only, and in that case, and they are connected in parallel, and in that case, if you are going to find the potential of find the capacity of each capacitor, I'm sure you will be able to get that it will be 22.2 picofarad. So the resultant capacitance, net capacitance of the system will be simply twice of H, and that will be 44.4 picofarad. And from that you can find the potential of the outer sphere, that you can write here simply as potential phi equals q divided by the net capacity we got. And in this case you will also get the result being 225 volt. And I know few of the students will make a potential mistake here, because they will going to make a mistake of simply regarding the outer metal ball and the inner metal ball, that is outer sphere and inner sphere, as a spherical capacitor with charges plus q and minus q. And if this were the case, there would be no electric field between the larger spheres, outside the larger sphere, no electric field outside the larger sphere, and so the metal ball would have zero potential, and we don't need to find anything else. In such a case, if you make this mistake, on the other hand, because of the electrical space between the metal ball and the outer sphere, the metal ball cannot also have zero potential, which it actually is, since it has been grounded. So this contradiction shows that the hypothesis of making a single spherical capacitor putting charges plus q and minus q on both the spheres is wrong. The inner metal ball must not be charged the same size as the outer sphere or metal ball, of course. And this makes our solution complete. So thank you very much for watching.